All right, we're going to do the chapter 1 and 2 review from Al Grosch's book, Developmental Math 2, starts on page 87. Okay, question 1. Add -7 plus 5 plus -3. All right, I like to do these by clumping them or grouping them together, starting with the negatives. I identify who's negative, so I have -7 and -3. Because they're the same sign, they get added together. That makes -10, and I still have the +5. And now since I'm adding two numbers that are different signs, they subtract. The difference is 5, and it's going to get a negative because the 10 had a larger value. On number 2, we're going to subtract 5.8 minus -2.8. Well, when you subtract a negative, these two negative signs can cancel to make a positive, and that's great, but you have to be careful that there are no exponents here. If there are exponents involved, you have to make sure you work those exponents first before you do this canceling with the two negatives. So this actually ends up being 5.8 plus 2.8. And of course, when you add decimals, you line them up, and you get 8.6. On number 3, we're going to multiply. -7 times 2 times -3. When you have all multiply, you can just count the number of negatives to decide whether the product should be negative or positive. If you have an even number of negatives, this is going to be a positive product. If you have an odd number of negatives, this will be a negative product. But since we have two negatives, that's an even number of negatives, this product is going to come out to be positive. And then we can just multiply. You know what, let's just do 7 times 6. We know 7 times 6 is 42, so this is a positive 42. Now we got some fractions going on here. 2/3 plus 1/4. And to add or subtract fractions, you have to have a common denominator. The denominator for 3 and 4 is 12. It's the smallest number that 3 and 4 both go into. So 3 times what makes 12? 3 times 4 makes 12. So I have to do a times 4 in the numerator. 2 times 4 gives me 8. 4 times what makes 12? So that would be 4 times 4. Whoops, no, not 4 times 4. What am I saying? It's 4 times 3. So times 3 on the top. 1 times 3. Now we can add these. When you add fractions, the denominator stays the same, and you just add the numerators. So 8 plus 3 makes 11, and this is 11/12. All right, number 5 is subtracting mixed numbers. So we have 4 and 1/2 minus 2 and 3/16. And again, to add or subtract fractions, they have to have a common denominator. You can leave the whole numbers and just change the denominators. The common denominator for 2 and 16 is 16. It's the smallest number that they both go into. So now we have to change the numerator. 16 times 1 is 16, so this one doesn't need to be changed. It's just going to be 3. But here, 2 times 8 makes 16, so I have to do times 8 on the numerator up here. So this new numerator is going to be 8. This is subtract. Denominator stays the same. 8 minus 3 is 5. 4 minus 2 with the whole numbers gives you 2. So this is 2 and 5/16. Number 6 is multiply. To multiply mixed numbers, you have to change them to improper fractions. So remember, it's multiply the denominator times the whole number, then add the numerator. So 7 times 3 is 21, plus 2 is 23. So this becomes 23/7. Same thing here. 13 times 1 is 13, plus 1 is 14. This becomes 14/13. And now if you remember cross-canceling, you can look to see if any of the diagonals have a common factor. And 7 and 14 are both divisible by 7. So when you do that, you end up with some new numbers. Divide them both by 7. So now we're just multiplying 23 times 2 across the top, which makes 46. 1 times 13 across the bottom makes 13. So 46 over 13. Let's change this back to mixed numbers. Since we started with mixed numbers, this is an improper fraction. The bottom is smaller than the top. To change it back to a mixed number, we divide. 46 divided by 13. And 13 goes into 46 3 times. That's 39 with 7 left over. That 7 becomes the numerator. The denominator is still 13. So this is equal to 3 and 7/13. All right, number 7 is divide. And again, you can't divide mixed numbers. You have to change them to impropers first. So the first one is going to be 4 times 2 plus 1, 9 over 4. And it is a negative 9 over 4. This is 13 plus 1, 14 over 13. All right, the rule for dividing fractions is keep the first fraction, change to multiply, use the reciprocal, or flip the second fraction. So we have negative 9 over 4 times 13 over 14. Again, I would like to cross cancel, but there are no common factors here or here. So what do we have? We have 9 times 13. Well, we have a negative times a positive, first off, which makes a negative. 9 times 13 is 117. 4 times 14 is 56. So this becomes negative 117 over 56. Now we have an equation here we're going to solve. 40 equals negative 8 times x minus 3. The first step, get rid of these parentheses, so we're going to distribute this negative 8. So 40 equals negative 8 times x, negative 8 times negative 3. Negative times negative makes positive, so don't mix up your signs there. We need to isolate this x, so we're going to start by subtracting 24. That leaves 16 equals negative 8x. And then we're going to divide by negative 8 to isolate that x. 16 divided by negative 8 makes negative 2. X equals negative 2. All right. On the next page, looks like we got another equation here on number 9. So let's zoom in a little bit. That's not what I wanted. There we go. All right. 3/5 y minus 4 equals 2. Let's rewrite it. All right, we're trying to isolate this y here, solve for y. So we need to add 4 to both sides. That leaves us with 3/5 y equals 6. And then if you remember from the lesson, to get rid of a fraction coefficient in front of your variable, you multiply times the reciprocal. So the reciprocal of 3/5 is 5/3. And of course, the whole point of that is then it doesn't matter whether you cross cancel them or not. Everything is going to turn to 1, and this becomes 1y. But, of course, the rule of equations, whatever you do to this side, you also have to do this side. So we have to multiply this 6 also times 5/3. So we're going to change it to 6 over 1 times 5/3. And you can cross cancel this 3 with the 6. They're both divisible by 3. And then you end up with 2 times 5 on the top, 1 times 1 on the bottom, which is 10 over 1, or y equals 10. All right, we're going to graph an inequality here. And start by writing the question. Negative 8 is less than 3x minus 6 is less than 9. When you have this compound inequality with the two less than symbols, it's nice to use the vertical lines to keep things separated, just like that. You're going to isolate your x here in the middle, so anything you do here, you also have to do on the left and the right also. So we're going to start by adding 6 to both sides, actually all three sides, just like that. And we end up with 18, negative 18 plus 6 is negative 12. We have 3x here in the middle because those 6's cancel, and we have 15 over here on the right. Now to isolate this x, we have to divide by 3. I'm going to do that on the right and on the left, all three places. So now we have x, and on the right, 15 divided by 3 is 5. On the left, negative 12 divided by 3 is negative 4. All right, that's just the solving part. We have to solve and isolate this x before we can graph. You can't graph it with all this stuff on your x. So we need to isolate the x first. Now we're going to graph. Okay, so I'm just going to scroll up. We have room right here to make a line graph. All right. The important numbers are 5 and negative 4. So I'm marking those on my graph. Just like this. And they are both open because there are no equal to bars here. So we have open circles here. Now we have to shade. Well, this part says x is less than 5. So we're going to shade less than 5. Less than 5 goes this way. If this part says x is greater than negative 4, or negative 4 is less than x, either way, x is greater than negative 4. So that's going to put the shading greater than negative 4 here, and this is what the graph will look like. The directions don't say interval notation, but we can practice the interval notation. The left boundary is negative 4 and it's open. The right boundary is 5 and it is also open. So that's the interval notation for this graph. All right, number 11 is order of operations question. Simplify. So let's write the question over. 6 minus 18 divided by 9 minus 4. If you remember order of operations, anything that's in grouping symbols first, so we don't have any of those. Exponents next, and we also don't have any of those. And then the multiply and divide left to right. So we need to do this divide right here that's in the middle before we do the subtracts. So negative 18 divided by 9 makes negative 2. The 6 carries down. The minus 4 carries down. And then we have just the add subtract part. If you do it like me, you're going to group these two negatives together and make negative 6 out of it. And then we have the positive 6 from right here coming down. So negative 6 plus 6 makes 0. All right, this is another order of operations question. 23 minus 8 times 2 divided by 14 minus 6 times 6. And again, grouping symbols first. So we want to work inside here first. Now, these parentheses could be grouping symbols, but there are no operations inside them. So they're not being used as grouping. They're just being used for multiply here. This is the only grouping symbol we need to do first. So 14 minus 6 is 8. We still have a times 6 here. We have a divide. I'm just replacing everything I haven't used up. And that takes care of grouping symbols. Next, exponents. Well, we don't have any exponents, do we? Next, multiply and divide left to right. And we do have a couple multiply. We have 3 of them. We have a multiply here, we have a divide here, and another multiply here. And we're going to work them left to right, which means we're doing this one first, then we'll do the divide, then we'll do this last multiply. So negative 8 times 2 makes negative 16. We didn't do anything with the 23 yet. Let's write this. This is an 8 divided by. All right, now we're ready to do this division. Negative 16 divided by 8 is negative 2. We haven't done anything with 23 yet. And now we're ready to do this multiply. Negative 2 times 6 is negative 12. So it looks like 23 minus 12 equals 11. Okay, on question 13, this looks a little confusing. I had a hard time reading this when I first read it, but these are absolute value bars right here, not number ones. So this isn't 18, this is absolute value. So we're going to rewrite it. Absolute value, 8 plus negative 14, and then close the absolute value, plus 9. So of course, we're going to work inside this absolute value first. So if 8 plus negative 14 makes negative 6, the absolute value of negative 6 means how far is this number from 0? It's 6 units away from 0. So this is 6 plus 9, which is 15. Okay, evaluate. Negative 6w squared plus 5w plus 3 when w equals negative 4. So we substitute the negative 4 in there for the w's, and the easiest way to do this is to use parentheses. So start writing the expression, put a set of parentheses every place you see a variable, and then go back and put your variable in where it belongs in the parentheses, and that way you won't lose your multiplication and you won't lose your negatives and your exponents and all that. So here we need to do this exponent before we do the multiply. So this is negative 4 times negative 4, which makes positive 16. We still have a negative 6 out here. All right, now we're ready to do the multiply. So negative 6 times 16 is negative 96. 5 times negative 4 is negative 20, plus 3. All right, these are both negatives. So if you like to do what I do and clump them together, that makes negative 116. And you still have the positive plus 3 on the end. And since these are opposite signs, subtract, take the sign of the bigger 1, you get negative 113. All right, number 15. Ooh, we've got an equation with fractions in it. So 6/5 y minus 2/3 equals 4. All right, you might remember from the lesson that when you have more than one fraction in the equation, it's best to clear the fractions first. We do that by multiplying every term times something that's going to cancel off with those denominators. So what number can we use to cancel a 5 and a 3 would be the least common multiple of 5 and 3, which is 15. So we're going to multiply the entire equation by 15. And that's going to involve distributive property of the 15 and then rewriting everything and doing some canceling. So we'll do that under here. We're going to multiply 15 over 1 times the first term, 6/5 y, minus 15 over 1 times the second term of 2/3. And don't forget, you have to multiply the 15 on this side too. You have to do it to every term, even if there's not a fraction. go 15 times 4. And I didn't use the fraction form of 15 because there is no fraction in this term. You could just use a regular 15. Now you can see the 15 should cancel with this 5 here, and the 15 will cancel with the 3 if you do cross-canceling. If you don't cross-cancel, it's okay. You're going to multiply across the top and then divide by 3. Multiply and then divide by 5. It's perfectly fine. I'm going to cross-cancel because I like to. 15 and 5 are both divisible by 5, so I get a 1 and a 3. 15 and 3 are both divisible by 3, so I get a 1 and a 5. And now I just need to multiply across the top. So 6 times 3 is 18. The bottoms are all 1. So this turns into 18y minus 5 times 2 is 10 equals 15 times 4 is 60. And now we just solve for y. To isolate this y, add 10 to both sides. So 18y equals 70. And then divide by 18. So y equals, okay, this will reduce, at the very least, these are both divisible by 2. So we can reduce it to 35 over 9. All right, number 16. Oh, there we go. Is a literal equation. So we have x equals negative 8z plus 7t, and the directions ask us to solve for t. So we're just going to isolate this t. To do that, we have to first add 8z to both sides. So that will cancel on the right, and we'll be left with just 7t. Over here on the left, though, these are not like terms, so be sure you're not writing them together in the same term. Okay? This should just be x plus 8z. And then you have to divide here. Get rid of this 7 here. Okay? And this is an okay answer right here. Sometimes we separate these terms and make two different fraction coefficients out of it, so we'll do that. This variable has a coefficient of 1, so when we make this fraction, it will be 1 over 7 x plus this fraction is 8 over 7z equals t, and this is a good answer also. All right, on the next page, we're just writing some expressions here. Let's read. 5 less than twice the square of a number. The result is 7 more than 3 times the number. Write the equation that could be used to find this number. Do not solve, just set up the equation. Okay, this grammar is a little bit awkward, but we can just take it word by word here and see what we can figure out. 5 less than twice the square of a number. Okay, 5 less than something means we're going to subtract 5 from something, but from what, we don't know yet. We just have to keep reading. 5 less than twice means we're going to multiply times 2, the square of the number. The square is the exponent 2. So this is 2 times the number with the exponent 2 on it. So that would be 2x squared. So let's reread it. 5 less than, okay, we have 5 less than, twice is the times 2. The square of the number is the variable with the exponent 2. The result is your equal sign. 7 more than means you're going to add 7 to something. We just don't know what yet. 7 more than 3 times the number. And that's going to go here. 3 times the number is 3x. So it looks like if we rewrite this equation, it's 2x squared minus 5 equals 3x plus 7. That's just a translate question. We have a proportion question on number 18. Write a proportion that solves this problem. A motorcycle can travel 705 miles on 19 gallons of gas. How many gallons of gas are needed to travel 1,253 miles? So remember, when we're writing a proportion, that it's all about comparing two different things. So start with the equal bars. We're comparing miles with gallons, and set up the same thing on both sides. Okay, and this part of the fraction comes from the first part of the story. A motorcycle can travel 705 miles on 19 gallons. So 705 miles on 19 gallons. How many gallons are needed to travel 1,253 miles? So the 1,253 goes here because that's miles, and the x will go here because we're looking for gallons. And again, we don't have to solve it. It just says set it up. So we're good. On this next one, we need to solve this inequality. So that means to isolate the x. And usually with the inequalities, we put x on the left. So I'm just going to rewrite the problem. Let's see. 14x plus 4 is less than or equal to 26x plus 20. All right. This is an x. Traditionally, we put all the x's on the left, so we're going to need to subtract this 26x. And when we do that, that's going to give us a negative 12x plus 4 less than or equal to, those will cancel, 20. All right, now we're trying to solve for this x. So we're going to subtract 4 from both sides. So negative 12x is less than or equal to 16. And now we need to divide by this coefficient of negative 12. Don't forget, when you're solving these inequalities, if you multiply or divide by a negative number, you have to flip the direction of this inequality. So this is not going to be less than or equal to anymore. It's going to be greater than or equal to. These cancel to make x, and this reduces to make negative 4 over 3. If you multiply or divide by a negative, it happens when you're getting rid of the coefficient. You have to flip the direction of the inequality symbol. So less than will turn to greater than. If it was greater than, it would turn to less than. All right, let's see what we got on number 20. If someone ran a 200-meter dash, how many yards is that? Okay, so these are conversions. So I like to do these with proportions. So what are we comparing? Meters to yards. Okay, we're starting with 200 meters. We're trying to figure out how many yards that is. And if you remember from earlier lessons, this is where your unit conversion goes. So you're going to want to look back on page 58 of your workbook to find out the unit conversions for these 4 questions. 20 through 23 on this page are all going to need you to look back to page 58 for those unit conversions. So I can tell on the unit conversions that 1 meter equals 1.094 yards. And then to solve these, remember we set up an equation with the cross products being equal. So x times 1, or 1x, will equal 200 times 1.094. So you need to multiply this out, and you can do that over here on the side. Remember, no calculators for this stuff. That comes out to be 218.8 yards. All right. On question 21, again, back to page 58, you're going to need these conversions on these last 4 questions, on this page anyway. If a container was filled with 5 liters, how many gallons was that? So again, we're converting liters with gallons. Okay, so we have 5 liters. We don't know how many gallons that is. when we look back on page 58 to get a conversion, we find out that 1 liter equals 0.264 gallons. And so then we can make our equation. X times 1, or X equals 5 times 0.264. And you can multiply that out over here. Pause the video if you need to. Go ahead and multiply it out. It comes out to be 1.128 gallons. All right, on number 22. If a person weighed 100 pounds, how many kilograms was that? So we're trying to convert 100 pounds to, we don't know how many kilograms. So we need a conversion for pounds to kilograms. It looks like 1 pound equals 0.454 kilograms. So then we're going to cross multiply again to get an equation. So 1 times X equals 100 times 0.454. So X equals, if you remember, multiplying times 100 just moves this decimal 2 places. So this should be 45.4, and the units are kilograms. All right, so on number 23, if the temperature was 90 degrees Fahrenheit, what is the temperature in Celsius? All right, I don't know if you guys remember from the lesson that when we talked about converting between Fahrenheit and Celsius, we could not use proportions because the formulas are not proportional. So we have to actually go, and again, this is on page 58 of your book, of your Al Grosch's Developmental 2 book that you should be working in. The formula for converting to Celsius. We know Fahrenheit. We're trying to find Celsius. So the formula we want to use is C equals 5/9 Fahrenheit minus 32. And we're going to put our Fahrenheit temperature in there and simplify this. The Fahrenheit temperature is 90. So of course doing 90 minus 32 first because it's in the parentheses, we get 58. And multiplying 58 times 5/9 is not really that fun, but what you want to do when you have something like this is rewrite it 5/9 times 58 over 1, and the 9 and the 58 unfortunately do not cross cancel, so you're basically multiplying 5 times 58 on the top, 9 times 1, and then you're going to divide because temperature is written in decimals. So multiply first, then divide. Or you could make this a decimal, the 5/9 a decimal, and then multiply times 58. It doesn't really matter. Pause the video, do all that, and then you can come back and check it with my answer, which is 32.32 degrees Celsius. All right, on page 90, we have some more word problems to practice on. So we're going to look at this first one. A jacket is priced at $75 but is on sale for 20% off. What is the sale price of the jacket? All right. If you remember in some of the other word problems videos, I used this little equation that I like to use with these percent discount questions. It says the original times whatever percent you're paying equals the new. All right. The original price for the jacket is $75. What percent are we paying though? It says it's on sale for 20% off. We're not paying 20%. They're taking 20% off. So we're paying 80%, which in a decimal is 0.8. We don't know the new price. All right. So to find the new price in this question, we just have to multiply 75 times 0.8. And again, you guys can do that off to the side. That comes out to be 60. So the jacket is now $60. On number 25, if a digital camera cost $375 after a 25% discount, what was the original cost? I'm going to use the same formula. The original times, let's not use that. The original times whatever percent you're paying equals the new. All right, we don't know the original this time. We know the new price is $375. The original is X. What percent are we paying? If it's a 25% discount, that means they took 25% off and 75% are left because they're always taking it off of 100%. So we have X times 0.75 equals 375. So, of course, to solve for this X, we have to divide by 0.75. That's a decimal. Both sides. And you can do this division off to the side. Pause the video, do your division, come back and check it. It's $500. All right, if a DVD player cost $690 after a 15% increase in price, what was the original cost? So the original times the percent you're paying equals the new. All right, the new cost is $690. The percent you're paying, okay, this is a 15%, but they're not taking it off. They're increasing it. So everything starts at 100, then they're increasing at 15%. So this would be 115%. 115% in a decimal is 1.15 because you move that decimal 3 places. And the original is X because that's what we're looking for. So to solve for this X, you're going to need to divide by 1.15. So you have X as being equal to 690 divided by 1.15, and that's, I don't believe that's really hard division. So you guys try it out over here and then come back and check it. The original price is $600. All right, number 7 is a simple interest question. 27. Find the simple interest percent to yield $100 interest in 5 years when $500 is invested. So you're going to have to start with the simple interest formula, which is I equals PRT. And then you're going to substitute the numbers in that you know. Find a simple interest percent to yield $100 interest. Okay, the $100 is the interest, so you can put it there instead of I. In 5 years, so 5 is the time, when $500 is invested, so that's the principal. So it looks like we don't have a rate. Well, it's asking us, find the simple interest percent, and that is the rate. So this over here, this is all multiply. You just need to simplify by multiplying 5 times 500, which makes 2,500, and the variables R over here is equal to 100. So to solve for R, divide off this 2,500, both sides. All right, and again, we're left with this fraction here, which we're going to reduce and change to a percent. So the fraction right now is 100 over 2,500. You can start by reducing those zeros off. So now we have 1 over 25. Percents are kind of fun if you can get your fraction to say 100 on the bottom. The percent will be the top because percent is always out of 100. So how can we get 25 to 100? We can multiply times 4, can't we? So multiply the top times 4. That gives you 4 out of 100, and that is equal to 4%. Of course, the traditional way would be to divide, but most people hate division, and multiplication is a little bit easier. If you can make your denominator into 100 on the bottom, the numerator is the percent. 4 out of 100 equals the percent. Or you can just do the decimal division to change this to a percent. All right, on 28. The length of a rectangular pool is 15 less than 3 times its width. Its perimeter is 50 meters. Find the length of the pool. So we're working with a rectangle again. So we have a rectangular pool. This is the length, and this is the width. The length of the pool is 15 less than 3 times the width. So we need to write an equation here for length. The length is 15 less than, means you're taking 15 away, 3 times the width. So that would be 3W. The perimeter is 50 meters, so I'm going to write the perimeter here in the middle. Okay, we need a formula. The perimeter of a rectangle, P equals 2L plus 2W. And then we're going to substitute some stuff in there. Since we know the perimeter, we can put perimeter here. Since we know that the length is equal to 3W minus 15, we can put that here instead of length. So that would be 2 times 3W minus 15. And then we have the plus 2W on the end from here. So this is the same plus 2W here. All we did really was replace 50 for the P because we know that's the perimeter. And the L we replaced with 3W minus 15. So this is the important part right here. And now we have an equation that has only a W in it, and we can solve for W. So we're going to start by distributing, combining like terms, and then isolate the W. So what do we have? 50 equals 2 times 3W, 6W. 2 times negative 15, negative 30. Then we have plus 2W on the end. We have some like terms here. We have a 6W and a 2W. That makes 8W. We still have a minus 30. Now we're ready to solve for W, so the first thing we need to do is add 30 to both sides. So plus 30 makes 80 equals 8W. Divide by the coefficient of 8, we get W equals 10. The question asks us for W? No. The question asks us to find the length of the pool. Well, we found the width. That doesn't mean you did something wrong. It just means that you're going to have to take an extra step now to find the length. And you've already expressed that the length is equal to 3W minus 15. So we're going to take the width, we're going to put it in here for length, and we're going to simplify one more time. The length equals 3W minus 15. So that would be 3 times 10 minus 15, because we figured that 10 equals W. And solve that down. 30 minus 15 is 15. So the length equals 15. What are the units? 15 what? Meters. The length equals 15 meters.